PSI, so does this have to be in PSI, and that's where the chapter's going to get you. Is it's going to be a converting game, because they're going to give you one in PSI and one in millimeters of mercury. And then you're going to have to convert one or the other. Does that make sense? You can choose any one you want. That's called unit congruency or unit consistency. All right, now temperature must always be in Kelvin. Temperature must be in Kelvin in this chapter. Let's write that down. In this chapter. Now check this out. Let's just say that you forgot and didn't put temperature in Kelvin. All right? So let's say that that's negative there. Everything else is positive. What would this pressure have to be? Negative or positive? No, wait a minute. If you've got one negative, everything else is positive, what does that one have to be? Negative. Period. Do you see that? So, because this is just multiplication and division. So if one thing is the only thing that's negative, see, how do you get rid of a negative when you multiply or divide? You have to multiply it or divide it by another negative. Okay? So what does that mean? That means you got a negative pressure. Now what is that? There ain't no negative pressures, because pressure is defined as a force of a molecule or an atom against a unit of area. So if you have nothing, which by the way you can't have that, but if you had nothing, then how could it push against something? Never mind if you had a negative nothing. Does that make sense? All right, look at this one here. V1, T1, V2, T2. This is the last law. Okay. Look at this one. Negative. If that's negative, then for example, that's got to be a negative volume. Does that make sense? So how can you have a negative volume? You can't. There ain't no way. You either have liquid or you don't have liquid. There's no you've got negative 12 liquids. Now certainly sometimes you can see negative 12 for a volume, but that would imply that water has drained out of something. All right. Not that there's a container that holds negative 12 milliliters. All right? How are we doing?
But it could apply to temperature.
No, you cannot have a negative temperature.
So this is not minus 3 Celsius? You cannot have that?
Oh yeah, you can have minus 3 Celsius, but then you have to convert it to Kelvin.
Okay.
All right? And when you convert it to Kelvin, there's something out there called absolute zero no one's ever got to.
Yeah.
But that is like a strict speed limit or a strict cold limit of the universe. You can't get colder than that. So that ensures that there is a positive number, even negative 250 degrees centigrade. There will be a positive number for Kelvin. All right? So, combine all this together to rightly be called the combined gas law. And this is the first equation. All right? So, it is P1 V1 over T1 equals P2 V2 over T2. It takes Charles's law. It takes Gay-Lussac's law. It takes Boyle's law. It adds them all together and gives you that. Now, how many variables do you have in that equation? 3? Come on now. How many variables you got? 6. Now, anytime you have 6 variables, how many must I give you for you to be able to solve the equation with one answer? 5, right? So that's why people love this chapter, is you have to be given 5 of these 6. Now, which 5? Who knows, right? And to be able to solve it. Because if you don't, then you've got multiple solutions. So let's just show you how this is done with a quick example here. I am on page 302, and here's what I've got. I've got myself, page 302, number 13. I've got myself an expandable balloon. All right, so let me draw myself a picture here, right? I got a balloon here. That balloon is going to go up into the air. Now, as the balloon rises, it's going to get bigger or littler? Bigger. Because there's less pressure up here, so this balloon will get bigger. All right? Like this. So you have a small balloon going to a big balloon as it goes up. What's so funny? Okay. Now, here's what the problem says. It says that it contains 1,400 liters of helium. Okay. It is at an initial pressure of 0.95 atmospheres, and it is at a temperature of 18 degrees centigrade. And that is right here, Jacksonville, Florida. And then what's going to happen is we're going to release it. Let this joker go 22 miles up, and here's what's going to happen. We're going to have a volume of God knows. We're going to have a pressure of 4 torr. And we're going to have a temperature of 2 degrees centigrade. How's everybody? Huh? Oh yeah, not ones, thank you. Twos. Right, because every condition down here would be classified as a 1, and every condition up here would be classified as a 2. All right. So we've went from some place that's relatively warm to a cold place, right? Because as you go up, it gets cold. You with me? Everest is colder than it is here. All right. You've also, okay. So, look at here. If this is in liters, what will this answer be when we're done? In liters, right? There's that unit consistency. Okay, so this is an atmosphere and this is in torr. That ain't no good. You need to pick a unit of pressure. Atmosphere, torr, PSI, kilopascals, I don't care what you pick. And they both have to be in the same unit. So which one do you want to pick? Torr. This man wants to pick torr. She wants to pick atmosphere. They're both the same answer. I just heard torr first. So this one's already in torr. Let's put a check mark. 1 atmosphere is the same thing as 760 torr. Atmospheres will cancel. So 760 times 0.95. $722 torr. All right. So again, I can put a check mark here because torr equals torr. There's nothing special about that. They got to be the same. Okay. Then we've got temperature. Now the rule says temperature's always got to be in Kelvin, period. So we're going to add 273.15 to this to give me 291.15 Kelvin. And then we're going to add 273.15 here to give me 275.15 Kelvin. Okay, looky here. Both of those now have check marks. So we're ready to start the problem. Now, what are we looking for? We're looking for V2. Would you prefer to algebraically rearrange this thing first or to plug in the numbers first? What's that now? Arrange first. Okay, let's arrange first. So here's where we started with. P1 V1 over T1 equals P2 V2 over T2. I'm looking for that, so